I am Shyamala Gaudi, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3301 Data Structures. Unit 5 Searching, Sorting and Hashing Techniques. The topic to be learned in this presentation is sorting. Under sorting, we are going to learn what is bubble sort and how it is implemented. Second one, what is selection sort and how it is implemented. Third one is insertion sort and how it works. First, bubble sort. This sorting algorithm is comparison based algorithm in which each pair of adjacent elements is compared and the elements are swapped if they are not in order. We take an unsorted array for our example. Bubble sort takes O of n squared time. Bubble sort starts with very first two elements, comparing them to check which one is greater. In this case, value 33 is greater than 14, so it is already in sorted locations. Next, we compare 33 with 27. We find that 27 is smaller than 33 and these two values must be swapped. The new array should look like this. Next, we compare 33 and 35. We find that both are in already sorted positions. Then we move to the next two values 35 and 10. We know that 10 is smaller than 35, hence they are not sorted. We swap these values. We find that we have reached the end of the array. After one iteration, the array should look like this. To be precise, we are now showing how an array should look like after each iteration. After the second iteration, it should look like the below array. Notice that after each iteration, at least one value moves at the end. And when there is no swap required, bubble sorts learns that an array is completely sorted. Second, selection sort. This sorting algorithm is an in-place comparison based algorithm in which the list is divided into two parts, the sorted part at the left end and the unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is the entire list. The smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes a part of the sorted array. This process continues moving unsorted array boundary by one element to the right. Consider the following depicted array as an example. For the first position in the sorted list, the whole list is scanned sequentially. The first position, where 14 is stored presently, we search the whole list and find that 10 is the lowest value. So we replace 14 with 10. After one iteration 10, which happens to be in the minimum value in the list, appears in the first position of the sorted list. For the second position, where 33 is residing, we start scanning the rest of the list in a linear manner. We find that 14 is the second lowest value in the list and it should appear at the second place. We swap these values. After two iterations, two least values are positioned at the beginning in a sorted manner. The same process is applied to the rest of the items in the array. Third, insertion sort. This is an in-place comparison based sorting algorithm. Here, a sublist is maintained which is always sorted. For example, the lower part of an array is maintained to be sorted. An element which is to be inserted in the sorted sublist has to find its appropriate place and then it has to be inserted there. Hence the name insertion sort. The array is searched sequentially and unsorted items are moved and inserted into the sorted sublist in the same array. This algorithm is not suitable for large data sets as its average and worst case complexity are of O of n squared, where n is the number of items. We take an unsorted array for our example. Insertion sort compares the first two elements. It finds that both 14 and 33 are already in ascending order. For now, 14 is in sorted sublist. Insertion sort moves ahead and compares 33 with 27 and finds that 33 is not in the correct position. It swaps 33 with 27. It also checks with all elements of sorted sublist. Here we see that the sorted sublist has only one element 14 and 27 is greater than 14. Hence, the sorted sublist remains sorted after swapping. By now, we have 14 and 27 in the sorted sublist. Next, it compares 33 with 10. These values are not in a sorted order, so we swap them. However, swapping makes 27 and 10 unsorted. Hence, we swap them too. Again, we find 14 and 10 in an unsorted order. We swap them again. By the end of third iteration, we have a sorted sublist of 4 items. This process goes on until all the unsorted values are covered in a sorted sublist. Thank you.